Okay, in the last video, we had discussed the three-stage connection establishment, data transfer, and connection termination phases of TCP. Uh, since the various events are happening during this three phases, how do we keep track of all these events? How do we represent them in a single state, a single place? Then we use the concept of a finite state machine. You might have studied finite state machines earlier also in data communication. So this state machine model shows us various states and transitions. So this entire TCP can be modeled as a state machine or a finite state machine. So in a finite state machine, we have a fixed number of states or the finite number of states. So in the next diagram, we see how this uh, the various events occurring during the TCP in between a client and server can be represented as a finite state machine. Okay, so the one that you see in the diagram here represents the TCP state machines, and it is actually a collection of two set of states used by both the client and server. Okay, these are actually clubbed into a single diagram. So when you are looking at the diagrams here, okay, so you have to understand certain representational features. uh, all the rounded rectangles here that you can see, either closed, listen, established, fin, wait, and so on, all of these represent states. Okay, so the states are shown using rounded rectangles, and the transition from one state to another is shown using arrows, okay, or directed lines. And on each arrow we see two strings separated by a slash. For example, from the closed state, if the client wants to move to the SYN-SEND stage, okay, from the closed state here to the SYN-SEND stage here, if the client wants to make a transition, it uses this directed line. On this directed line, you can see uh, two strings, and these strings are separated by a slash. For example, here we have an active open slash syn. So out of these two strings, the first string represents the input, which is what the TCP receives. And in um, with respect to this input that it has received, the second string represents the output, what the TCP sends in response to the input that it has got. So whenever a client wants to open a connection, for example, it places an active open request, that's the input, and in response to the active open, the TCP sends a SYN message here. Okay, so this is how the labeling of the transitions are done. So there are two strings separated by a slash. First one is the input and second one is the output. And the transitions are marked in different line styles. So any transition or an arrow symbol using a solid line or represents the client transitions. Okay, these are related to clients. Similarly, the dotted lines represent server transitions, and the colored lines, those shown in blue, represent special situations. Okay, they could be either the client or a server transition. Okay, so this is the notation with regard to the state transition diagram. So rounded corner rectangles are the states. Okay, so directed lines are used to show transitions. Solid lines are shown for clients and dotted lines for servers. On these lines, the first string is the input and second is the output, and the color transitions show special situations. And if you look at the diagram here, in between we have a state called as the established. This state established is actually two set of states. Okay, one is for the client and another for the server. And this established state later we will be using to explain both flow control as well as error control. Okay, but looking at this complex finite state machines, it becomes difficult to understand all the phases. So to simplify it, we look at some scenarios. Okay, we take a specific scenario and then model it with a much smaller state transition diagram. Before we move on to those scenarios, let's also look at certain states that are going to be present in the finite state machine. So in the very beginning we have the closed state at which there is no connection between the client and the server. Next you have a listen state. Okay, so this is with regard to the server. Whenever it receives a passive open, it moves to a listen state and it is waiting for a SYN request from some client. Similarly, after a client has sent a SYN, okay, it is said to be in the SYN sent state and it is waiting for an acknowledgement. After it has got an acknowledgement, okay, so after it has after it has got a SYN received, then what happens is in response to the SYN it has received, okay, it will send an acknowledgement and also send a SYN request in the opposite direction, and it now waits for the acknowledgement to come in the opposite direction. Okay, and established state we have discussed already, where the connection establishment happens and data transfer continues. Once there is no more data to be transferred, okay, then we have the fin wait one phase where the client issues a fin and it is waiting for the acknowledgement from the other side. And when the acknowledgement is received, it uh, for the previous fin that it had sent, it is set to go into fin wait 2 and it is now waiting for the fin from the server side. Okay, so uh, when the first fin is received and in response to this, when an acknowledgement is sent, so this is from the server point of view, so a fin is received from the client and the server responds with an acknowledgement and it is now put into the close wait stage and it is waiting for the application to close. And on the client side, when a second fin is received, okay, so first fin was sent by the client and even and now if the server also wants to close, um, then it sends a second fin. When this second fin is received, we say that it is in the time wait phase, and now we will not directly close the connection. We are going to wait for some amount of time which is called as the 2MSL. Okay, this 2MSL is something that we will discuss with regard to timers lately. And finally the closing state is where after both of them have received the fin request from either end and got their acknowledgements, respective acknowledgements, they decide to close. Okay, as I was saying, rather than trying to understand this complex finite state machine, we'll break it into smaller scenarios. So the first one that we are looking at is a half close scenario with respect to the client. Okay, so this half close scenario can be specified both with respect to the client and server. So first we'll look at the client process. Okay, so initially the system is said to be in the closed state when there is no connection, and uh, the client TCP gets a active open command from its client process, which is at its application layer. Okay, suppose say there are two processes at the application layer which want to communicate. Okay, one being the client and the another server. So the application process on the client end will send an active open command to its corresponding TCP, which is at the transport layer, and it is requesting a connection to a specific socket address or a port. Now what happens is, after sending an active open to its TCP, so in response to this, now it has to start the connection establishment. So the TCP, in response to the active open is the input, will send a SYN segment. After sending the SYN segment, it now moves to the SYN sent stage that you can see in the diagram, and it waits for the acknowledgement from the server side, and it continues till it receives an acknowledgement. From the other end, the server will reply back with an acknowledgement and at the same time also send a SYN saying that it wants to establish connection from the other side as well. So now the client, when it receives a SYN plus ACK, SYN is for the connection request from the server and acknowledgement is the acknowledgement from the server side. The client also accepts the connection from the server side and sends an acknowledgement. Okay, that's the output of this. So when this operation is done, okay, when the client also approves the connection of the server and the server has already approved the connection of the client, we now are set to move into the established state. During this state, all the data is transferred. Okay, and this connection is duplex, as we know, so data transfer can happen in both directions. And it is not only data transfer but acknowledgements also. These acknowledgements flow in the opposite direction. Now let's say that the client and the server have finished the data sending. So now the client wants to terminate. What it does was, it issues a active close command. From the established state, you can see there is a transition. The input to this transition is, it will happen when the client issues a active close command, which generates a fin segment. So when the client process says that it wants to close, in response to this, the TCP sends a fin segment. And when it sends the fin segment, it is set to move to the state finwait 1. From established, it moves to the finwait 1 phase stage. And when the client receives this fin segment, the client sends an acknowledgement, okay, saying that okay, I'm okay to terminate this connection. At this point, it is set to move to the time wait state, and from the time wait state, the client waits for 2 MSL seconds, which is the timeout. Okay, it waits for some amount of time. It doesn't immediately terminate the connection. It waits for this special time called as 2 MSL. Okay, so this MSL we will study in TCP timers shortly. After this timeout occurs, the TCP is said to come back to the closed state. Okay, so this is the half closed scenario with regard to the client state. You saw here how the transactions are triggered. These transactions just are triggered because of the input, and and what is the output of this is shown on the second string, and this input and output are divided by a slash or separated by a slash. Okay, and we saw various states. Similarly, now let's look at another scenario with regard to the uh, server state. Okay, so if you look here again in the diagram, initially the process we are said to be in the closed state, and let's say that the server application says that it is now ready to accept connections from its clients. So then the server process will issue a passive open command, and by issuing a passive open command, the server TCP is set to move from the closed state to the listen state. Okay, you should see the transition on the left hand part. Okay, from closed we move to the listen state, and in response to the passive open, no messages is going to be generated. That's why the output is just shown as a dash. So once we are in the listen phase, the TCP continues to look out for any requests from clients. So when it receives a SYN segment from a client, then it can no longer be in the listen state. Okay, so looking at the SYN received, it will send back a reply acknowledging the just now received SYN, and also sends a SYN packet saying that it wants to establish a connection from its end as well. Okay, that's the output. Okay, so now after doing this, it is set to move into the SYN received state. Okay, so the server has received a connection request from the client, and at the same time it also has requested for a connection to the client in the opposite direction. So now it is in the SYN received state. When it receives an acknowledgement, okay, when the server receives an acknowledgement from the client, uh, which is okay with the connection in the opposite direction, then when this acknowledgement is received, the server is set to make a transition to the established state. In the established state, as we have discussed, the data transfer is going to happen. And similarly, the server continues in the stage till some till the client wants to terminate the connection. So the uh, TCP client, when it sends a FIN segment, okay, then the server will move on to the close wait state, and in response to the FIN saying that yes, it wants to agree, it will send an acknowledgement in the reverse direction, and now it is said to be in the close wait state. And what it does is, it doesn't send a FIN request, okay, a close request for the connection immediately. Rather, it is said to be in the close wait, and it is still keeping the connection from the server to the client direction still open, because there could be still some computation being done on the server's end, and it cannot immediately terminate the connection. When it receives a uh, explicit close command from the process, then what it does is, it will write down all the data to the server, whatever is in the queue. It will write down all the data to the server and sends an acknowledgement. Okay, at this stage it again goes back to the closed state. Okay, when the server receives an acknowledgement for its request to terminate its connection from its side, from the client, then it moves back to the closed state. Okay, so this is how we can understand the excuse me, the various events that occur using a finite state machine. Okay, another way to understand all the events is to look at the same scenario with the states represented over a timeline. Okay, over a time period, we can represent these actions or events by states, saying that the TCP is in this initial state, and at a later point of time, because of a particular transaction, it has converted into an another state, and so on. Okay, so if you look at the diagram here, the client side process uh, sends an active open input. If you look at the timeline prior to it, okay, so the timeline is, it is starting from the top and moving in the bottom direction. As we move in the bottom direction, it means that a time is being elapsed. Okay, you can see it here. This arrow shows that time is increasing in the bottom direction. So initially, the so what you see this box as transport layer is the TCP. Okay, so we see a client side TCP and a server side TCP. Both of them are in the closed state. Okay, the black shaded state is said to be the closed state. The server at some point will issue a passive open. So when the server is ready to accept connections, it goes into passive open, at which case the server changes from close to the listen state. Okay, so now the server is waiting for any request from the client. Similarly, let's say at some point the client has sent a request for a connection establishment by sending a SYN. Okay, so before it gets an acknowledgement, till that point it will be in the SYN sent. Okay, it will change from close to SYN sent, and it is waiting for the acknowledgement to arrive. So when the server replies back with an acknowledgement and also a SYN in the opposite direction, client is set to get into the established state. And the client also has received a SYN request from the server. So the client sends an acknowledgement saying that it is okay to start the connection. At this point, okay, the data transfer can happen. So if you see in the diagram carefully, even though the client has moved into the established state, okay, just after the SYN sent state, okay, here you see that the data transfer does not start immediately. Okay, the data transfer happens when the server has acknowledged. Okay, when it receives this acknowledgement, at that point the data transfer starts. Then after some time, the client, when it is finished with the data transfer, it sends a fin message. Okay, the client process will issue an active close, because of which the client TCP moves from established to FIN wait1 state, and here this FIN request has been sent to the server. So when the FIN request is received by the server, and when it sends an acknowledgement, it moves from established to a closed wait stage. So what is the difference between FIN wait and closed wait? FIN wait is waiting for the acknowledgement for the FIN request. During the closed wait, okay, there is only unidirectional transfer of data. Okay, client can no longer send the data because it has terminated its connection. Okay, whereas the server can still send data. From server you can send the data to the client, and clients can send acknowledgements in the opposite direction. As you can see here. Okay, after some point in time, when the server also wants to close the connection from its end, it sends a FIN request. At this point, okay, the client moves into the time wait, okay, which is waiting for some 2 MSL time. After the timer expires, it goes to the close, and before closing it, the client would also have sent an acknowledgement saying that yes, I have received a FIN request. So when the server sees that its FIN request has been approved, it will also move into the close state. Okay, so this is another way of understanding the different events happening during TCP by using a timeline diagram. Okay, this is an alternative representation of a finite state machine. Okay, so